Hello everyone. In this video, we are going to take a look at conditional probability and independence. Recall that probability is a number between 0 and 1. And conditional probability, even though it's conditional, it's still probability, and so it should also be a number between 0 and 1. So be very careful in questions. Whenever they say find probability, you always expecting a number between 0 and 1 as your answer. Okay, so I'm going to start with just an intuitive example of what is conditional probability. Remember that whenever you want to, for example, find probability of something that has equally likely outcomes, it's going to be favorable over total. Now, in this case, imagine that you are looking at a card from a distance, and the card is a face card, so you can tell there is some face on it, okay? But you just can't tell what it is. Is it Jack, Queen, or King? So what is the chance that the card is going to be king? First of all, you need to look at your total. How many total cards are you choosing from? So you're now not choosing from 52 cards because you know it's a face card and there are 12 of them. So that's your new total. And then the favorable is going to be how many kings are there? Well, that's 4. So the answer should be 4 divided by 12. So you can see that now we're not dividing by 52, but we are dividing by the condition. The condition was the face card. So that is also 1/3, which shouldn't be surprising because king is just 1 out of 3 possibilities, Jack, Queen, or King. All right. Now let's go back to our table example and let's look at these questions, conditional questions. First of all, how do I know it's a conditional probability question? If you read the question, it starts with if an 18 to 34-year-old adult American is randomly selected, what is the probability that that person is a social media user? How do I know it's conditional? Because there is an if part. Sometimes they start with the word given. And also that, by the way, condition can also happen at the end of the sentence. For example, I can say, what's the probability that he, she is a social media user, given that person is 18 to 34-year-old? The answer will be the same no matter where that given part is. And you always have to divide by the total in the condition. What's condition? 18 to 34-year-old, because that's the if part. So now you're cutting down your universe, okay, to just those people in the first age group, 18 to 34, and then looking at how many of them are social media users. Well, that would be 117, but again, this time we're not dividing by the grand total, we're not dividing by 530, we're dividing by the total in the condition. So that would be 0.78. Okay, now let's look at one more example. If a social media user is randomly selected, what's the chance that that person belongs to age group 1? Now, what is your condition? Always concentrate on the condition. The condition is social media user. So you are cutting down your universe to now just social media users. How many of them are 18 to 34-year-old? Well, there are 117, but now we are dividing by 338, which again is the total in the condition and the total in the social media. So you're not going to get the same answer. Okay, so definition of independent events. Two events, A and B, are independent if the occurrence of one of them does not affect the occurrence of the other. How can that happen? So imagine that there are two events. A is it's going to rain in New York City, and B is it's going to rain in Tokyo. Are these events independent or not? Suppose I tell you that it is raining in Tokyo. Is that going to affect the chance of that it's going to rain in New York City? No. So that means the events are independent. And the definition is that probability of A given B is equal probability of A. So whether you give me B or you don't give me B, it doesn't matter. It's going to be the same probability. And vice versa, probability of B given A, you can just hide the given A. It doesn't matter because it's not affecting B. It'll be probability of B. Okay, now there is a difference between mutually exclusive events and independent events. And this is really not the same thing. So let me give you an example. Suppose you have event A that it rains in New York City, and event B, it does not rain in New York City. Well, these events are mutually exclusive because they cannot happen together. It either rains or not, but they're not independent because if it rains, right, then I know it's not raining. Okay, so there is a dependence. It's either one thing or the other happens, right? So one of them happening affects the chance of the other, because then it's going to be zero chance of the other. So that means mutually exclusive are not independent. Independent actually do happen together. It's possible that it rains in Tokyo and it rains in New York. It's just that there is no connection between them. Okay. All right, so let's look at the multiplication rule. So this rule actually follows from the definition, and I'm not going to explain it or prove it. You're just going to have to use it. It is equivalent to the definition of independent events. So how do we check if two events are independent? By using this rule. So if two events are independent, then probability that they happen together, E and at the same time. So remember, the and in probability means both at the same time. So probability of E and F is probability of E multiplied by probability of F. Okay, so this is the rule that belongs on your note card. This is something that you will have to check. If it's equal, then yes, independent. If it's not equal, no, not independent. And reverse is also true. If it is equal, then independent. If it's independent, then equal. Okay. Let's look at the first example. Suppose I know that probability of E is 0.3 and probability of F is 0.5, and I know that E and F are independent. What is the probability that both of them happen? Well, the multiplication rule says the probability of E and F is just a product of these two. So all I have to do is just multiply them. Well, multiplication rule, okay? So that means that probability of E and F is going to be 0.15. Okay, now let's say we want to find probability of E or F. So I want you to remember, especially for the test, anytime you see the word or, you are using additive rule. What does additive rule say? Probability of E or F equals probability of E plus probability of F minus probability that they both happen at the same time. Well, we already know what they are, so we were given that probability of E is 0.3, probability of F is 0.5, and we just found probability of both happening, and we were able to multiply them because they're independent. So if we, by the way, if we weren't told that they are independent, you can't multiply them, but we were. So that would be 0.65 here. Okay, for the second example, suppose that probability of one event is 0.6, probability of the other one is 0.5, and probability of both is 0.3. Are they independent? So A here is the chance that somebody's taken a math class, B is somebody's taken a science class. Well, we need to check out the condition for independence. It has to happen that if I were to multiply P of A times P of B, that should give me the overlap. So if I were to multiply 0.6 by 0.5, do I get 0.3? Well, yes. And that means that the events are independent. Okay, one more example. Suppose that the chance event D is the driver drives a domestic car, and the chance of that is 0.6. Probability that the driver has an accident is 0.04. We know that the two are independent. There is really not much of a relationship whether you are driving a domestic versus foreign car and an accident. At least we are told that there is no relationship. Okay, so what is the probability that the driver drives a domestic car and at the same time has an accident? So this both at the same time. So according to multiplication rule, we can just multiply these, and that's going to give me 0.24. Now, the last example I want to consider, and I promise that that would be it, is whether events social media user and 18 to 34-year-old are independent or not. So in the previous video, we actually computed all the pieces that we need for this, because we just want to know, are they independent? So how do we check that? By condition of independence. Is probability of both social media user and at the same time 18 to 34-year-old is equal to the product of the individual probabilities. So going back to our computations, which if you go back to the video, the previous video, we knew that social media user was 0.683, first age group was 0.283, and the chance of both is 0.221. So let's multiply 0.683 times 0.283. and that gives me 0.193. Is that equal to 0.221? Well, no, it's not. So what does that mean? It means that these two events are not independent.